AT4 is all about injection, surjection, what that means in terms of our linear transformations. And the very first question is pretty challenging. There were multiple parts to it. We wanted to talk about the relationship between injection and surjection and these ideas we had previously of linear independence in spanning when we talk about vectors. So for the most part, we did a pretty good job, or we really understood that injection was tied to the idea of linear independence, and that our surjection, our function being onto, was related, come on, you can highlight, to spanning. We just missed out on the vocabulary and very much missed out on this one piece right here of identifying a set of vectors we were referencing by name or with an example. So talking about a transformation being linearly independent, that doesn't make sense. Talking about a matrix being linearly independent, that doesn't make sense. What we want to talk about is a set of vectors and those vectors being linearly independent. So most folks who got a 1 out of 2, that was the mistake that happened, is we didn't clearly reference that set of vectors and where one would find that set of vectors in relationship to our linear transformation. And I will give you that the baseline question here from TBIL didn't provide a whole lot of context for us. So if you wanted to, you could have gone ahead and been like, okay, we're talking about some transformation T from some vector space V to some vector space W, and that might make this a little bit easier. But if you didn't, you still should have been able to do this, right? So first off, we need to talk about our set of vectors. 2 ways that we could talk about that set of vectors. We could talk about the columns, and maybe we'll even be better about this, and we'll say like the set of vectors formed from the columns of the standard matrix. And we should tie this back to our transformation. All right, so this is one way to talk about it. We could talk about the set of vectors from that columns of that standard matrix of the transformation. I'm realizing now I don't love the way this wording is going to work out, but I'll fix it. If this set is linearly independent, then we can say that transformation is an injection. So maybe I'll try to if is linearly independent. Then our linear transformation. And see, this is where there's just so much more writing to be done if we don't have like T defined as this linear transformation. So part of the reason maybe on version 2, I'll give you a little more of that context so it's not as much work to sort of write about these things instead, is injective. All right, so all we did here was link, but we did this part about the set of vectors, and I already got distracted because there's another way. And I'll actually just use the other definition for our second statement here. So linearly independent. Oh, that's not what I wanted. I wanted the cute blue. I thought I selected it. Linearly independent, we have injective. All right, so let's talk about surjective. Again, we need to talk about the set of vectors. So let's just say if, and now we're going to use the other way to write this, up to you. I think most students know about the columns of the standard matrix. It's just fine. This would be the transformations. Oh gosh, I still want to say set of vectors. Set of vectors formed, formed is probably a not decent word, but it's okay. From the transformation of the standard basis vectors And here's again, I just kind of want more. I'm going to go ahead and use the TVW stuff. in V, right? Because we want to say we took the standard basis vectors in our domain, we mapped them, and now we have images in our codomain, right? Those results, those are how we create our standard matrix. One of the ways we can create our standard matrix. So if the set of vectors formed from the transformation of a standard basis vectors in V span, and we definitely, here was the piece, right, where we got in trouble again. So we have this idea of span. We're about to, this thing does not like changing colors. We have not said surjection yet. We went ahead and defined this set of vectors in a different way, but it's the same. We need to say what we're spanning. And since I have written this out, W, if you didn't write it out, you have to write our codomain. And many were very good about this. Just writing that they span is not enough, right? What the heck are they spanning? Because every set of vectors has a span. We need to span the entire codomain so that our image and our codomain are the same, right? So if that's true, then I didn't have an N over here. Our transformation T is surjective. Beautiful. Okay, so those are your two options for that set of vectors. I didn't need you to get quite as in the weeds with the writing the whole set of vectors, but using the word matrix, using the word transformation, just saying columns but not referencing the standard matrix, right? There were a lot of ways that we flirted with this and didn't quite get all the way there.